put the education in the hands of the students. And it's hugely successful, but it has to be done really carefully. And it has to be done in a way that it actually is guided.
600 students and 6 people, right? None of those is a professor. So the whole thing is based on people learning together. And when I had a chat with Vint Cerf about the model, he's like, you know what? This sounds like the early internet. This is when people were just looking at the source code and learning from each other, and that there was no professors. So I'd love for you to go a bit into that. Do we need the professors? What do we need them for?
It doesn't necessarily have to be them talking to and just expounding and giving out all the knowledge. The knowledge is absolutely available and usable, but it has to be guided. And that's very different than the traditional professor teaching. They do their own problem solving. They figure things out themselves. But if they run into trouble and they are at a place where they can't figure it out, which happens with students all the time, and that's where the professor,
right,
that's where that guide comes in and has to do it in such a way that's still empowering and unblocks them. Because that's where the knowledge transfer, it has to happen in that moment where they're blocked. You have to figure out how to deal with that. And that's not necessarily one size fits all. That's going to depend on the team. It's going to depend on the block that they're experiencing. But getting them past that and then getting them back on track and doing it in as natural a way as possible, that's hard. And that's the new kind of teaching that you're talking about.
So every time a student writes code, the way that it gets checked, basically, the way that it gets evaluated even, is through peers and the feedback that you get. So in my understanding, that's very close to how you really work in the top companies where you have enormous code bases. And obviously, before even the smartest engineer can contribute something to a big code base is by having other peers looking at it.
We can't hire trainers. All of our engineers have to teach because it really is, state of the art. So there isn't anybody out there that can come into Google and train our engineers. They have to teach each other. So we set it up within our education organization so that it's as easy as possible for a really brilliant engineer to just get all that out of his or her head and into a form that we can use to teach. So it's peer learning everywhere, right? In terms of the way that knowledge is transferred internally, because that's the only way to do it. We can't do it in the normal, let's bring in the expert and have the, from outside or whatever. They have to be teaching each other. So it's just kind of a part of the culture. You have to know a language or a technology fairly, significantly before you can be in a position to do code reviews for someone who may be more junior or just starting out. So there's a lot of training that goes around being in a position to provide that feedback in appropriate ways. But it's pretty much everywhere, and just in terms of the way teams operate and how the structure is set up with the tech lead and with the kind of mentoring that goes on just around the technology. It's really built in pretty much everywhere you look.
So, hello and welcome to the 42X podcast. Today, we are chatting with Maggie Johnson, someone I've worked and lived with for more than a decade. We know each other since the times of my postdoc when we came very young and idealistic to help bring peer learning and good education inside of companies. And Maggie was already at Google and at Stanford and was interested, and we've stayed in contact ever since. And she's really been a mentor and a manager at times of mine. So I'm particularly happy that you took the time to chat with me today.
Oh, happy to be here, Max. Thank you.
So just a little bit in terms of where you come from and what you do today. And then, of course, you're more than welcome to compliment or correct anything that I'm saying. So for quite some time, you have been running university education, university relations and educational programs, engineering education programs in particular at Google. I think that's more than a decade at this point. But it has been rewarded by you climbing up the ladders and being the VP for education and university programs and COO for the research product area, which I know is at least 2 full-time jobs. God knows how you do that. But the latter one really being added in the since I've moved back to Germany. And I'd love to also learn a little bit on how that is making you excited and finding new ways for Google to be present in that research environment. And interestingly enough, you haven't directly started with tech. That's where a lot of your passion went in the last years, but you have started with studying early music performance and actually performed as a musician for quite a while. I'm sure you get that question a lot, but if there's any similarities and cross-fertilization points, I'd be really interested in that as well. So, without further ado, Maggie, how are you today and what did I miss? Are there any aspects that you'd like to compliment to my introduction?
I'm doing well, and thank you again for having me. The only thing that I would add is that I think the theme through all of this, through my entire career has been teaching. Even when I was a musician, that's what I loved to do the most was to teach. I could still remember the pinnacle of teaching at that point was like if you're teaching music history or music appreciation in a university setting, and getting engineers to actually appreciate Mozart or an opera and actually sit and listen to it and understand it was really challenging and really satisfying. And that was, sort of the beginning of my teaching career. And then obviously at Stanford, that was really the focus. In the computer science department there, we worked a lot on trying to figure out at that point in time, it was really not quite understood how to put together a curriculum where the content just changes constantly. It's just like every year there's a new programming language or a new tech stack that you have to learn. So there was a lot of work at Stanford and with our colleagues elsewhere to figure out how to kind of pull out what are the foundational aspects that no matter what tech or program, whatever you might be doing to implement things, that foundation always is consistent. And that was a big part of what we were doing at Stanford at that time. It was really interesting work, and it's sustained, it still is kind of the way we think about teaching it. And then of course at Google, a lot of what I do is education and teaching. So that's sort of been the theme, and it's great because that's what I do. So that's all. I think that's all I would add. But
yeah, and I think it's maybe what connects us as well in a way, because this understanding, in order to teach, you have to have a fascination for the knowledge at hand, right? For that skill and that competence, and then analyze it and go through in a variety of ways. And frankly, maybe we get to it a little later. In the approach that the school that I'm leading now, 42, has, it's totally practice-based, right? It's all about doing it. And one question that we're asking ourselves is, what are the meta skills, right? What are the lasting elements that you want to learn? And I think we have a fairly good answer in terms of the mindset that people need, right? That learning to learn, that continuous learning, that appetite to continue to update. But clearly the part of what are the underlying themes is more reflective, I would say, and therefore, more theoretical, right? More meta in a way, and that would be interesting to see how that develops inside the 42 schools, and how maybe the two concepts, university education becoming a bit more practice-based and 42 becoming a bit more of a top layer, or adding a top layer of meta thinking.
Yeah, it is interesting because you're sort of at the middle ground between like what we teach at Google and what we teach at Google is all practice. It's all practice-based. It's specific tools and technologies you need to get productive and do the things you need to do. And then a university education, which can be more theoretical, but at the schools that really prepare students the best, for what's, going to happen in industry, they tend to be practice-based too. Some of the things that we learned about how to prepare students for a career of constant change is to just throw the different languages at them.
Right.
It's like the intro course is in Java, the next course is in C++, the third course you got to learn 3 languages in 1 quarter. It's just like really changing it up on them all the time so that they get used to that and they have a sense of how they need to adjust. And then the other thing that kind of experience allows them to do is that when they see so many languages, and when you actually study programming languages, for example, you get to a place where you can see the commonalities. And once you see the commonalities, it's so much easier to learn a new language. So there's that kind of thing that's present. And then there's also, in places where, they really prepare students well, it is team-based and it is practice-based. It's, you don't read a book on operating systems, you write one. And you write one in a team setting, so that you're learning. It's kind of the theoretical underpinnings or a compiler. You actually write one. And then not only do you understand then how these really important tools and technologies work, but you built it with a team and it's practice-based. It combines it in a really interesting way. So yeah, and I think 42 is like one of the best examples of the practice-based, peer-based, capturing really what it is to do that in an industry setting. And it has, it comes at the end of a kind of long evolution of coding boot camps and university, computer science programs, and it's combined a lot of the best of both. But that evolution has been really interesting to watch. If you go back, just a few years ago, the reason that coding boot camps kind of popped up is because there was just such a demand, with cloud and with machine learning, and such a demand for software engineering skills, way out, way more demand than supply, right?
And that's still the case. We're far from having that covered. So I already took 4 points that I want to react to, and I think that's fine too, Maggie, if we're passing balls back and forward. But we should also have a look at the good show notes that we prepared beforehand. But I would love to hear a couple of words on how you see peer learning happening at Google, because one of the examples that I think are really well thought through in the 42 model is the peer reviews. So every time a student writes code, the way that it gets checked, basically, the way that it gets evaluated even, is through peers and the feedback that you get. So in my understanding, that's very close to how you really work in the top companies where you have enormous code bases. And obviously, before even the smartest engineer can contribute something to a big code base is by having other peers looking at it. So training the students to do these peer reviews and actually also give feedback, not just to your fellow student, but also to hear back how that feedback was, right? So to learn how to receive and to give feedback seems to be something really important. Then the next aspect I took a note for is the aspect of you mentioning that the best way to learn about operating systems is write one. And that reminds me of quotes of really good game developers, like board games is more where I'm nerding out. And you can't develop a game, and I assume it's the same for a computer game, by just writing, thinking it through. You actually need to get in and try it out, and then you adjust it. And I love that way of change of even engineering, right? You could take it even further and say machine learning and writing code for machine learning is more in that fashion because you're feeding it that training data, right? So the whole idea, it's almost going from Kepler to complexity sciences, right? A way where the world is all fine and clear, and you have your Mozart that's following exactly the order that is there versus jazzing and jamming. So that was two. I have actually more points, but I want to hear from you more than I want to hear you talk.
Well, the first one, I think the code review idea is absolutely core to how we do software engineering. And it's not just Google. This has been around forever. This is and that is a peer learning model. And it is, there's so many examples of it at Google. I'll just give you a couple more. Max, having been at Google and having worked with me on the onboarding program at Google, that we can't hire trainers. All of our engineers have to teach because it really is, state of the art. So there isn't anybody out there that can come into Google and train our engineers. They have to teach each other. So we set it up within our education organization so that it's as easy as possible for a really brilliant engineer to just get all that out of his or her head and into a form that we can use to teach. So it's peer learning everywhere, right? In terms of the way that knowledge is transferred internally, because that's the only way to do it. We can't do it in the normal, let's bring in the expert and have the, from outside or whatever. They have to be teaching each other. So it's just kind of a part of the culture. And then code reviews, as I mentioned, are really important. And there's a lot of training and what we call readability capabilities. Like you have to know a language or a technology fairly, significantly before you can be in a position to do code reviews for someone who may be more junior or just starting out. So there's a lot of training that goes around being in a position to provide that feedback in appropriate ways. But it's pretty much everywhere. And just in terms of the way teams operate and how the structure is set up with the tech lead and with the kind of mentoring that goes on just around the technology, it's really built in pretty much everywhere you look.
Cool. So last one on the direct back and forward, but I think the readability is something that has always fascinated me. And one aspect that might be a reason why I have never become a really good coder is that you have to be incredibly precise and have to show a lot of rigor when it comes to, reviewing your own code and making sure it follows the style guides, etc. And when I joined 42, one of the slides basically had a list of things of qualities that 42 students had, and rigor was one of them. And I was like, come on, how are you, really transmitting that? But the theory that I came up with now, and I'd like to see if you see something there or not, is that because it's peer reviews on the one hand, but once you decide that you're done with your project, you have to hand it in, and a machine basically validates or doesn't validate your code. And in order to get validated, it actually goes through all the style guide aspects, including, how you make commas, how you name variables, like really the details, where a human might probably say, yeah, the program is good, she's passed, right? But that program is ruthless. I mean, if there is a mistake in your the way you write the comment, it doesn't pass. And that was where I thought, okay, maybe actually if you go through that for a couple of years, you do get a training in being fairly rigorous.
Yeah, I mean, it's interesting too, because one of the things that is really hard to simulate in a more academic environment that is present in industry is just the discrete nature of the work you do in school. You take a class, or you finish this module, or you finish this project, and you move on to the next thing. And at a place like Google, you could be working on the same project for 5 years. It never ends, So it's that sense of how you organize your time and your thinking and how you get into the details of a product or a technology over many, many months and years is really hard to bring that experience into an academic environment.
True, and maybe that's not, certainly not the way to start, right? In the beginning, you do want to.
No, I think it's right. I think it's right. But this is what you do, internships and you do things like that, where you do get to dabble a little bit and see what it's really like, and compare that to what you're experiencing in academia. But we bring in so many university graduates into Google, and we've learned a lot about what that transition is for them, and what are some of the challenges they face in going from one environment to the other. And this is one of the ones that's just really quite difficult for them to work through, that it isn't discrete anymore.
True. So usually the first question I ask on this podcast is, what's the question I should be asking? And you've come up with a question that I think makes a lot of sense. And it is, how does a program like 42 fit into the ecosystem of higher and post-higher education for computer science and software engineering? What is your thought in that regard?
Well, we've already touched a little bit on this. It is really interesting to look at, why these kinds of programs emerged a few years ago. And we already talked about one aspect of it is the demand for these skills is just in the pipeline coming out of university programs, not nowhere near big enough. And that's one part of it. The other part of it is that, colleges and universities all over the world are really struggling. If you look at in the US, the business model these, institutions have are hundreds of years old, and they've gotten to a point where they're just so ridiculously expensive, and they are so not preparing students, at least from a parent's perspective, for a career, that's failing too. So, what are the alternatives then for students to get the skills they need to actually start a career? And that, I think all of that kind of about, 6-7 years ago really caused this emergence of all these coding boot camps. And in the beginning, they were kind of, give me 6 months time and $18,000 and I'll turn you into a coder, and it's, definitely they could do that. They could build you can learn Python, you can learn JavaScript or whatever, and be in a position to practice that skill in an industry role. But I think the things that they learned over time is, number one, that depth we talked about that you get from a university program is not there. So they learn one skill. And when that skill changes, they have to go back to school. Whereas if somebody's gone through a program like 42 or a university program, they learn enough depth that they can adapt and continue to learn what they need to learn on the job, or continue to grow that way without having to go back and learn a new skill. So that's one of the issues with that kind of boot camp. And the other is that they didn't prepare them for all the other aspects of being in industry. It's how do you communicate? How do you interact with people? How do you work on a team? All of those kind of soft skills, which you also get inadvertently through all kinds of university experiences. In a 6-month boot camp, you're just, that's pretty hard to build all that in, as well as building the technical skills. So, a lot of them started in sort of a naive place, where it's like, let's just get the skill and then get them into a job. And then the really good ones have evolved. Some of them require people to have a university degree. It might be in English literature or whatever, but at least they have, the soft skills covered. And then you have 42, which is really kind of at the place where it has the depth. It provides all the kind of soft skill. It does that, and it does it in a project team-based way that's very reflective of, what happens in industry. So I think that it's, 42 is at a very evolved state, because there are all these other kinds of boot camps still exist. But the really good ones have really looked at what worked and what didn't work, and have gotten to a place where they're kind of in between a university program and what's happening in industry. And those are the ones that are really the most successful. And I would put 42 in that place.
Very cool. So let me see if we are on the same page, and please disagree if you disagree. I think the shorter the training, the more it is on the vocational, let's prepare a skill, as you said. The question that I would like to ask is if the lack of supervision, right? The lack of teaching that is actually happening at 42 is something that in the end produces students that feel more in control, possibly are more entrepreneurial, right, to do something, because they're used to solving problems themselves, and they don't have that picture of somebody of authority, right, like the professor. I wanted to come to that point earlier already when you said that you love teaching, because that's something that we don't do, right? I mean, I have 600, not yet, but I will have 600 students and 6 people, right? None of those is a professor. So the whole thing is based on people learning together. And when I had a chat with Vint Cerf about the model, he's like, you know what? This sounds like the early internet. This is when people were just looking at the source code and learning from each other, and that there was no professors. So I'd love for you to go a bit into that. Do we need the professors? What do we need them for? And the second aspect, sorry if I'm packaging things up a bit, is how important you think the physical contact, obviously we're in times of Corona,
Yeah.
We're all used to doing things pretty much only online. I think we do see the limitations of that, but for an educational setup, we are doing, like in general, 42 is an in-person school, and we have people come here, sit together, etc. But now, of course, we have to move online. And what are we losing? Is it possible? What is an ideal hybrid situation possibly that you can imagine?
That's a long question, Max.
Yes.
Let me start with the first part. You hit on something that's actually really challenging for me, because the thing I really like about teaching is taking something that's incredibly complex and figuring out how to present it so that people can understand it. But that doesn't have to be, me standing in front of a classroom with students and lecturing. There are many, many ways to do that, which I've learned at Google. So, that is totally not the only model, and it's maybe not even be the most effective model. But that is a thing about teaching that I think most people who teach is that's the passion, is to be able to help people understand. I think when you were talking, I was thinking about Esther Wojcicki, who you may know. And she's just one of the most gifted and most prominent K-12 teachers in the United States. She started up the journalism program at local high school here, which is just world renowned, and it is all peer-based learning. It is project-based, it's peer-based. It's teacher as coach, and it is not, and her whole thing is to put the education in the hands of the students. And it's hugely successful, but it has to be done really carefully. And it has to be done in a way that it actually is guided. So that's where your 6 people come in. It doesn't necessarily have to be them talking to and just expounding and giving out all the knowledge. The knowledge is absolutely available and usable, but it has to be guided. And that's very different than the traditional professor teaching. And she's really figured out how to do it in such a way that she empowers her students in the ways that you just talked about, where they do their own problem solving, they figure things out themselves. But if they run into trouble and they are at a place where they can't figure it out, which happens with students all the time, and that's where the professor,
right,
that's where that guide comes in and has to do it in such a way that's still empowering and unblocks them. Because that's where the knowledge transfer, it has to happen in that moment where they're blocked. Because if they're able to kind of move along and are moving along fast enough and things are coming together, which will happen, because it's, they will be able to do that because of, whatever you're doing to bring in the students with the capabilities. But that's the critical point. And that's the place where, you have to figure out how to deal with that. And that's not necessarily one size fits all. That's going to depend on the team. It's going to depend on the block that they're experiencing. But getting them past that and then getting them back on track, and doing it in as natural a way as possible, that's hard. And that's the new kind of teaching that you're talking about.
And if I may, I think that there is also this aspect between training where you would, or you could classify it as training is, you know what you're training, it's clear what to do, right? And you're basically supervising that training, that the knowledge is happening. While we actually have a word in German, Bildung, which basically means more education for life, right? What we call maybe humanities, or you're about life things, I guess, how to position yourself in life. And those are the questions where there is no right and wrong, but you need someone to or it's super helpful to have someone on your side to speed things up and to come to insights. That said, and I'm just, I'm very new to this role, and I haven't seen the 42 students struggle. But what my peers from other locations tell me is that they let them hang there for a while, actually.
Okay. That could be the right way,
Say it again.
That could be the right way, yeah.
I think is, you need to find exactly the right timing and to understand the student in a way, because it's so much more fulfilling. I think we both had that experience that, you're struggling with something, and then at one point you epiphany, that energizing moment where, you have done it as well. It gives you a lot of confidence in
it does. It's really important.
While if, you're feeling somebody's pampering you along, and, that is the whole fear of being a fake syndrome that even very successful people have, right? Because we are full of self-doubt. And so I think that's really why I'm so happy that we found a great pedagogy lead who's thinking exactly about that and looking at the profiles. That's the tea leaf reading, at least in the beginning, right? He's looking at these profiles and saying, oh, this student hasn't made much progress in the last week. Maybe we should have a conversation. And when to actually help, to teach how to fish, or just say, hey, you have to try a little harder, to give that extra confidence. It's going to be really a great.
Yeah, it is state of the art. It really is, and it's very interesting, and it's where we need to go. It's just that is so much more. It's just so much better preparation for life, and for whatever they're going to encounter in their career than the traditional approach.
Yeah. Because of the complexity, and you mentioned about the complexity in technology, but I'd claim that complexity has risen in all our life dimensions, right? Political, economical, on the one hand, the positive view is you have the freedom to work and go anywhere in the world, and the difficulty is, okay, but then where do I go and where do I belong, and what
exactly.
do, right?
Yeah.
I think the Brexit slogan, "Take back control," was incredibly strong because it spoke to the heart of where people's fears are, right? They feel that they're losing control over so many things. And, of course, it's the EU and globalization and technology. That's a fairly easy answer. And I think the more you feel in control, and you give people that education how they can control things. Those are aspects that are not very elaborated in the 42 curriculum in the moment that I'm personally very interested in and would love to think through with you amongst others. Really looking forward to that ride. So coming to the second official question, and I already can tell that we won't be able to get through all of this, but you've mentioned state of the art. We've talked about trends and developments. Now, the question we put in the show notes is, how will our educational system look like in 50 years? And of course, that number is totally random. I just don't want you to feel held back by, oh, but our tax system won't support that, or things like that. How would you like to see it develop? And if you think it's utopian, what are the aspects that you think might need a special attention from us?
I think that what we're already seeing is that there are alternative pathways to get the skills and the experiences that you need to have a successful career and or whatever it is that you might want to do with your life. Traditionally, it was high school and then college, and get your bachelor's or master's or whatever you feel you need to do what is necessary, if that's even available to you, and it's certainly not available to everyone. But that really was the only path, other than vocational, really skills-based types of things. And what we're seeing now are just many, many alternatives for getting started and getting to a place where you can actually start having a productive and a satisfying career, which I think is great. To have everybody think that the only way you can do this is go to a 4-year college has just been so constraining and so unavailable to so many people. And to have, even a 3-month or a 6-month coding boot camp, get somebody started, that's huge. And I think we're just going to see more over the next few years. We're going to see more and more of these types of pathways that are more and more becoming acknowledged by employers as being valid, because there's a lot of companies still that are like, if you don't have a bachelor's, we don't want to talk to you. And that's changing. It's changing at Google. It's changing in a lot of places, which is good, because these are the things that are becoming available to students that, it gives them more opportunities. And we as employers, we have to be willing to acknowledge those and really get out of the frame that that's the only way that it's going to work. So I think we're just going to see more and more of that, and more innovation here, in some of these sectors, because like income share agreements are, what a wonderful innovation, right? To not have to pay anything. And then when I actually have a meaningful job, to give some percentage back to the school that got me here. And, colleges and universities are doing this now. So to see that kind of innovation sort of growing in this space is really cool too. So I think we'll see more of that. And then I just think we're going to just see a lot of different ways that people can make their way forward, which is good. It's a market now. There's a huge need for it. So there's a business there.
I agree. And in terms of the skill set, on the one extreme, you'd see everybody coding almost like writing, right? That you're literate and that we're all coding in one way or another. On the other hand, you'd see, technology is kind of that there is the cast of technology experts that keep things running, but most people focus on creativity and their human skills, right? Because our sophisticated machines can take care of things. Where do you see things going in that direction? And what I don't want you to look into a crystal ball. It's more like what trends you observe there, and what you would recommend young people to do, to look into.
I think the trends, and we're in the middle of this, in our K-12 programs at Google, we do a lot of work in this space. We have a lot of programs that focus on coding for middle school students, for example, just so that they have some experience with it. Mm-hmm. It's not to create a bunch of software engineers. It's to, help them understand how this works, since this is a critical part of their life. So it's more for that understanding.
Yeah.
I think that the need for everybody to code, I think, is overblown. I don't think I think everybody should try it, again, so that they have an understanding of how the technology works and to see if it's something they're interested in. What I think is way more important are sort of what we think of as foundational but modern digital skills. It's not just being able to use spreadsheets and word processors, or, it's not, of course you need to know all that, but that's sort of, elementary school kids learn that now. But it's things like data science. It's how do you make decisions with data? How do you work with data? Because the thing that we haven't talked about here is AI, machine learning, and how that is just blowing up everywhere. It's a part of healthcare. It's a part of your car. It's everywhere. And that means that whatever field you go into, there's going to be a point in time, if it hasn't already happened, where these types of systems for decision making in that context or in that domain, they're doing that based on data. So as people work more and more in that kind of a environment, which is changing, that these systems are really becoming very well developed and predictable and reliable. And they're all working on data. So one of the things that we do a lot in our programs is to really try and build up instincts about how to work with data and how to understand that, do I have enough data to actually, understand what's going on here? Is it clean? Is it biased? Is there everything? Do I need, do I have everything I need? And then once I have that data, how will that be used? And, there's just a whole set of new things that even 10 years ago weren't as relevant. But if you look forward 10 years, these systems are making their way into every single domain. And if you're going to be working in those domains, you have to understand how the systems work, at least in order to trust and use them and explain them. But it's a doctor, or it's it's an accountant, or it's a lawyer. That you still need to be in those domains, but you have to be able to work with these systems now.
And it's deeper than, let's say, just a tool that changes, right? I think in a number of ways, it really it goes to the heart of the matter of almost you having a sidekick with certain positive and negative qualities, and you need to know your sidekick as good as possible, because only then can you judge when it's when it's
exactly
giving you really good advice and when not. There's an example of where Google worked with doctors on an imaging system, and just to improve the acceptance rate, they basically overlaid the help that they got from the system on the microscope. And by really including it in the usual tools that are used, the acceptance rate really went up a lot. And I think these type of it still feels like something that's coming from the outside, and from what you just described, that understanding would make it much more innate in the different professions. So I think I see what you mean, and that is a really fundamental development for all professions, really. It
really is. Yeah, I think we're going to see more and more of these systems playing bigger and bigger roles. It doesn't mean that the people aren't equally important, because having what we call a human in the loop for many of these systems is really quite important. But they're just really, really sophisticated tools like we've never seen before that will really change, how people operate in those spaces.
And you had suggested the question to think or to speak about the coming technologies that are influencing educational efforts. Is that certainly is one of them, right? To learn about it, also to use it in education, the machine learning techniques and data.
Yeah, well, it's the data for sure. I wouldn't expect, a clinician or a doctor to understand the machine learning algorithms that's driving a diagnosis system that they might be using, but to understand at least the high-level algorithm, and then understand how the decisions it makes might be biased one way or the other, because you'll never have a perfect data set. So it's just new instincts on how to use that and how to trust it. It's like you were saying, you need to be able to understand when it's screwing up, because it will, just because it's not going to ever be perfect. but to have those instincts. So I think that is definitely one of them. But as I said, I don't think everybody needs to learn to code to be in those, not at all, but I do think you have to understand enough about the system so you trust it and you know how to use it in effective ways. And that's probably more technical and more data based than what most people think. The other trend I think we might see just on the machine learning front is, there's been a just explosion of models and ways of using them, and it's just sort of seeped into everything as we've been talking about. And these machine learning model or AI, people kind of conflate those two terms. The way those models are being built is changing. We're moving to a place where rather than having smallish models that are application specific, we might get to a place where there's a very large model that you could plug into. And that will be a very different way of thinking about this. It's almost brain-like. It's like, oh, you've got this great big model that's doing all this stuff, and you just plug into the right place, and then you can get your application running from that. So it's kind of going in that direction, and that'll be a big shift, in terms of at least the way people who are really in building that technology. That will change things quite a bit.
So let me see if I understood that correctly. I haven't seen that trend and thought about it. So you're saying on the one hand, it's becoming a bit more commoditized, so you can throw kind of known like TensorFlow or something will become
absolutely
something that okay, it works for this and it doesn't work so well for that, but okay, so a bit more Lego bricks, but then at the same time to evolve these from these base blocks to more sophisticated systems is where kind of the art is then.
I think it's actually easier for an application person and that's one of the the motivations for going in this direction is rather than have to create a new thing for every application. And you're right, it is becoming commoditized. So it's not like I can go to various open source or various, there are models that exist that work in finance now. It's not like I have to create that, but somebody did, and it is very application specific. What we're trying to get to is a place where you as a software engineer don't have to know so much about machine learning in order to use the technology in your application. There'll be things you can plug into that allow you to have those capabilities, but you don't have to build it yourself. That's a trend that I think we're going towards.
Okay. And I guess we're both a bit biased, but I know TensorFlow is clearly one of those systems that you probably also do quite a bit of work in terms of education.
And do you do any machine learning or AI based curriculum?
We do have a specialization on machine learning. I'd love to follow up and learn more
sure.
After the call. One aspect that was hot when I was in the Valley and we were working together was, of course, cardboard. And, the idea of bringing simulations, experiences to people. To be a bit provocative, I thought it was quite sad to see it, the expectations go so high and then it dropping really drastically afterwards. At least that's what I saw. But maybe you had different perspectives. And do you think it was just a hype? And yes, there is a place, but it's very limited. Or
let me ask you a question.
Is there more to it?
Let me ask you a question, Max. Why do you think it went from such high expectations to we can't do anything with that? What do you think happened in terms of commercial sort of interest, or just why did that happen?
Well, I mean, we both know these Gartner hype cycles, right? Like something new comes up, people have super good ideas, especially some programmers and people in the industry, especially analysts who make their money talking about the next big thing, say they found the next big thing and they get everybody excited, and so there is inflated expectations, and then it drops, and so I'm not necessarily surprised that it did, but I'm surprised how deep it dropped, and that I hardly see any development. I mean, Oculus Rift is still around. I've seen, you see a Vive every now and then, but it. My view would be this takes another 10 years to really get to something where you continuously want to use it, and it's awesome, and it has its use cases, and that's not a perspective that is taken many times by the private sector, right? So maybe it has gone back to research. To public research places. I don't know, putting it back to you. I tried my hand.
No, I think that's all totally valid. Sometimes the world's just not ready for whatever it is, because I mean, we tried to make the cardboard and a phone. We tried to make the technology as simple as possible for anyone to be able to experience some AR, VR kind of thing, and people didn't use it. It's like, so maybe we were before our time, like you said, in 10 years, maybe it'll be, and I think a lot of people find it a little creepy too, to just be in a completely different world while I'm still sitting right here. And that might be, I mean, this whole evolution of technology and the internet and all the things that you talked about, this is like total immersion into something else, and that does take a little bit of a mindset to want to get into that, and maybe we're just not there yet.
Yeah, no, I agree. It's a bit awkward to sit next to someone who is plugged into VR. Totally. That person is basically not there with you, right?
Yeah.
And especially if it's more of a private setting, you're like, I wish my wife would be here with me, type of thing. But to come back, we looked for educational use cases, and I think I would certainly recommend someone who comes to me and says, "Hey, I have an interest." I think it's a good time to start because there is this long runway. So you're not writing something out or looking at something that is not.
I mean, we had expeditions
in front of it, and technologically, it's certainly interesting.
Yeah, we did have expeditions, which was exactly that, and tons of field trips and things that students could experience again with cardboard and a phone, and built up a whole library of those. And even then, a very small number of teachers had enough phones and enough equipment for that to be available. But there is just wonderful educational applications in this. If you think about all the different ways that you can teach and simulate environments where, very specialized types of teaching, a lot of that's still going on. And VR is really useful in that sense. But that's very specialized. But I think you're right, that is definitely a use case that is powerful with that technology.
Cool. So last but not least, I think a lot of our listeners would be interested to get some insight, some tips from you on the recruiting practices and how you basically, what you're looking for at Google when you're hiring technical employees. Maybe not just SWEs, maybe you can talk a little bit about the spectrum of roles as well.
Yeah, there in engineering, there are a large number of different roles. I mean, software engineering is a big one, research scientist is a big one, but we also have program managers, we have technical program managers, we have technical writers, we have people who specialize in reliability, in production.
And a lot of those have a background in coding, right? Or are
for sure. Yeah, definitely. We call it software reliability engineering, and those are the people who run the production systems. Whether it's Google or YouTube or whatever, they make sure everything's up and running and troubleshoot with whatever might go wrong. System administrators, and then all kinds of levels of management. So lots and lots of different roles that have different requirements in terms of technical skills and technical knowledge. And obviously each one of those is sort of, we assess candidates in different ways, depending. For software engineers, and we have been really looking carefully at all our hiring practices over the last 2 or 3 years, and we're changing things to be much more of a, much less of a stand at a whiteboard and write code, and much more of a, let's give you some time to really think about this. Let's give you the mentoring that you might need, because it's just such a unrealistic environment to assess someone, for 45 minutes in front of a whiteboard,
Right.
and just trying to write a piece of code.
Like some people interview very well.
And that's not necessarily, you just don't get, well, first of all, you don't necessarily get a good sense of their technical skills, depending on how nervous they are and how well prepared they are. And then you also want to be in a position where you can actually talk to them and understand, how well they communicate, how comfortable they are working on teams. And so we're moving to a place where it is a little bit more like here's a half a day. Let's just have you, solve a problem and have the time you need to actually think about it. And maybe have a couple of partners, whether they're employees or other candidates, work on a team. And so this is where we're going. We're not there yet, but we definitely see the need to have an experience where we can assess candidates in a more natural environment and more comfortable for them, and where we can assess more than just the technical skills. So, and I think you'll see a lot of high-tech companies moving in this direction, because not only is it more comfortable, it's more inclusive. It really allows for everyone to do their best and to be their best in that period of time. But the technical skills are obviously critical, and those are the things that, there are lots and lots of ways to prepare for those kinds of questions or interviews or those kinds of things. It's all on the internet. The questions are out there. A lot of it is data structures and algorithms based, and the reason for that is because it's a set of smallish problems that really illustrate as quickly as possible someone's ability to not only have some kind of again, knowledge of the basic set of data structures, algorithms, and so forth, but to be able to apply them and apply them in natural and innovative ways. You can really just tell a lot in a very short period of time with that particular set of content. So I would really encourage your students to make sure they got that really almost instinctively, really internalized, so that it's just like talking. It's like your very basic language.
Funny, I thought exactly about that. They say to write code, but it's more like talking. You want to be fluent in it and really feel at home. And that was super interesting, Maggie. I can so feel the energy and that enthusiasm that you obviously had when you started with the music, and that took you to the technology, and it's still there many years later. And that's very, very encouraging and great to know that you're looking to provide this evolution also to work with everybody at Google to bring this next generation of coders on, and to bring the evolution that we all want to see in the tech space and in education.
Thank you, Max.
Thank you so much for your time.
Thank you.